Good day to all of you. I'm happy and glad we are meeting again for the second video lecture on Municipal Water Treatment Part 2. So I hope you enjoyed watching the previous video on Municipal Water Treatment Part 1. So we were talking about how water can be purified. We were talking about the initial and the basic steps that include water and its treatment. We were speaking about the requirements of boiler feed water at an industrial point of view. And we also started exploring about the several steps that are involved in clearing out water out of its contaminants for domestic view. So this is called the municipal water treatment, and we are continuing with part 2 in this session. So last class, if you remember, we were talking about the disinfection methods and we stopped exactly there. We were talking about employing bleaching powder. We were talking about adding chlorine. And then we were also talking about other simple methods like boiling. We started with the factors that affect chlorination. If you remember, the point we stopped with was about the contact time in which chlorine is being added to water. We shall continue discussing this topic from now on. So the second factor that involves adding chlorine to water is about the temperature of water. So higher the temperature, greater is the rate, and the killing of microorganisms also takes place at a very fast level. Now, when we talk about the pH value of water, lower the pH, faster the reaction, and a small contact period is required. Of course, adding chlorine to water is very advantageous because it is very effective and it is very economical. You require very little space to do this operation. The disadvantages: excess of chlorine generally produces very unpleasant odor and taste. Just imagine you drink water from probably you're traveling and maybe from a railway station or maybe in a bus stop or somewhere you buy water from outside, maybe from a restaurant. You just start drinking water. Sometimes such water is really unpleasant in smell and in taste. This is because it may be chlorinated water. So, as a good chemist, as a good industrialist, as a layman, anybody should know about the amount of chlorine that needs to be added to water because excess of chlorine will definitely produce a lot of other difficulties. So practically, probably you cannot drink such water. So how much should this chlorine level be? Generally, the free chlorine should not exceed between 0.1 or zero point 0.2 ppm. It can be more effective below 6.5 and less effective at higher pH values. So let us start exploring into this graph. This is called the breakpoint chlorination or the dip point chlorination. This highlights here about the free residual chlorine that is released out of the reaction. And most important of all, we are going to talk about how much chlorine is actually essential to be added to water to make it impart its original quality in killing the microorganisms and in being a good disinfectant. Look at the point, students. When you initially add chlorine to water, okay, it first kills or first it oxidizes all the organic matter. It reduces all the reducing substances. Maybe the free ammonia that is left behind, the free chlorine that starts killing the pathogenic bacteria. And this particular point is what is called breakpoint chlorination. So you can see the graph here. This graph here is a plot between the amount of residual chlorine released versus the amount of chlorine added. So you have in the x-axis the amount of chlorine added, and in the y-axis we have the residual chlorine that is released. The addition of sufficient amount of chlorine to oxidize organic matter is taken as an account here. So initially, when you add chlorine to water, okay, all the reducing compounds that are present gets removed completely. Okay, so in better words, there is formation. So the all the compounds that are present in water start reacting with the added chlorine, and it starts forming new compounds. You can call them as chloroamines. Okay, and you can also form compounds of chloroamines, which start showing as a point in the curve. You can see the curve raising upwards slightly, and this is because of the formation of chloroamine. So once all the chloroamines are formed, of course, it gets unstable. So there happens to be a destruction of the chloroamines. So everything starts getting reduced. Okay, first we initially had reduction, and now we will have the oxidation process. So all the chloroamines that were originally formed now start getting oxidized. So they get destroyed, and this is shown as the dip in the curve. The last dip in the curve, okay, you can see the pointer there. I'm showing you the pointer here. So this particular point is what is called as the breakpoint chlorination, because this is the extent to which chlorine has to be added. Because once the oxidation process is complete and all the chloroamines that have been formed and all the other chlorocompounds that have been formed are completely destroyed. Okay, so after this point, you will have free residual chlorine that is released into the system. So from this particular point onward, you can see the curve raising upward. This curve explains that all chlorine that is added to the system is simply introduced as free residual chlorine. So this point is what is called as the breakpoint chlorination. So I repeat again, when we talk about breakpoint chlorination, it talks about the addition of sufficient amount of chlorine that is necessarily added to water to first of all oxidize the organic matter, the reducing substances, and then release free chlorine, which is responsible for killing the microorganisms that are present in water. Okay, I hope you were able to understand this graph. So this particular point is called the breakpoint chlorination. So after this dip, you will have the free residual chlorine that is being released. The addition of chlorine beyond the breakpoint will create free chlorine only. So this is called as the uncombined chlorine that will act as the disinfecting agent. So this is the equation that is determining the amount of combined chlorine present. So combined chlorine can be obtained by reducing or minusing free available chlorine from the total chlorine present in water. So usually all the taste and the odor will disappear at the breakpoint. What are the advantages? So breakpoint chlorination will give us a clear idea about how much chlorine is to be added. That's the first point. So it initially oxidizes the organic matter, the ammonia and the reducing agents. It removes all the colors present in water. It can destroy all the disease-causing bacteria. It removes the odor from water. It prevents growth of weeds in water. So chlorine is a very good disinfectant, and with the practical information on breakpoint chlorination, we are able to focus better on how much chlorine that needs to be actually added to water. What are the disadvantages? So if excess chlorine is water, as we have already discussed, it releases residual or free chlorine, which imparts bad taste and odor to water. So dechlorination must be done in order to remove the free chlorine. Dechlorination is done by passing sulfur dioxide or sodium sulfate. So there's a method by which you can remove the excess chlorine that is being added to water. The next method is by adding chloroamine. So we were discussing about adding chlorine directly in water. Now we are talking about adding chloramine. So chloroamine, when added to water, produce HOCl. Of course, we know HOCl is a germicide. It can act over the microorganisms, kill them, and it can reduce all the contamination present in water. Chloroamines can be prepared by passing chlorine gas into ammonia chamber. So nowadays, municipalities use chloroamine and they treat it as a very good disinfectant to clear water out of its impurities. The next method that we are going to see is called UV treatment. So UV disinfection system is a very extremely effective way to fight against the microbial contamination present in water. Microbes have to be exposed to UV light in the proper amount in order to effectively disinfect water. Now, when we talk about UV disinfection systems, there are a lot of benefits when we talk about UV methods. For example, it's very natural, it's environmental friendly, very effective. In fact, it's very economical, and it is safe and chemical free. So how do we expose UV light to water? So we can expose UV light of the wavelength of about 253.7 nanometers to water. So when exposing water to UV light, it causes disinfection of bacteria, viruses, molds, algae, and all other microorganisms which multiply and grow. So UV disinfection destroys the DNA. If you look into a close proximity, we understand that it starts killing the DNA of the microorganisms, leave them dead, and they don't allow them to grow any further. So this technology is used for wastewater disinfection and surface disinfection as well. The last method that we are going to talk about is called ozonation. So we were talking about chlorination, we were talking about UV treatment. Under chlorination, we employed so many compounds and we were explaining about which can be advantageous, which is practically possible, and which is more disadvantageous. We were also targeting on what is called breakpoint chlorination. So the last method that we are going to discuss is called ozonation. So ozonation is simply adding ozone to water. So this can be added by passing it through an ozonizer, where when ozone added to water releases nascent oxygen. So this acts as a germicide and it starts killing the microorganism. Ozone is quite unstable, so it easily decomposes to produce nascent oxygen. So you can see that equation there. So what are the advantages of this method? It can remove chlorine, it can remove bad smell, taste, etc. If ozone is in excess, it is not harmful, unlike chlorine, which was a big disadvantage as we have discussed earlier. Disadvantage, this equipment is quite expensive probably. That is the reason we are not able to employ it in many places. Okay. So students, I hope you were able to understand about municipal water treatment. So municipal water treatment involves a lot of methods. So as good chemists, as good engineers, as good industrialists, I think it is high time we know about how municipal water treatment actually takes place, how it is making the society get beneficial. So nowadays we have a lot of complaints raised about water treatment methods, but definitely processes and the methods that we have explained so far has been of great commercial value, and it is of lot of practical utility to the public, and municipal water treatment hopefully was understood to all of you. Thank you again for your patient listening. Okay, we hope to meet you with more video lectures in the future. Hopefully, I hope that I was able to give in some information regarding the processes that are involved in municipal water treatment. Meet you again with another interesting video lecture. Thank you so much, students. Happy day, all of you.